This is the third video in the series and where it all comes together. It's time for our character to start throwing some punches. So far, we've implemented lock on and we've created hitboxes and hurtboxes to send and receive events. And previously, we were able to get a cube to hit our punching bag, but we want an actual use case and not just a proof of concept. Our character will jab, and if it connects with the punching bag, we will apply a force and emit a particle. First, we're going to need the SMB events that were covered in our previous video. We have the event and the event curator as well as the editor script to go along with it. Second, we need an animation. This is a left jab, and as usual, I got this from Mixamo where you can get animations for free. Then, let's set the import settings. Humanoid, XSpot avatar, and apply. Then in the animations tab, we don't want it to loop, bake, original, bake, feet, no bake, original, and apply. Next, we'll add this to the animator, having it return back to the base with an exit time of 0.85. Then, I'll add another input named attack, and I'll set the key code to be mouse 0 or left click. Going into the character controller, we'll work on playing that animation. I'll add a new bool in animation. This will be used to lock us out while the character is jabbing, and a string that holds the name of the animator state. Additionally, we need a reference to our curator. In start, I'll get that reference, and if you've seen some of the other videos, you'll know that we need a method to register to the event of that curator. On SMB event, we'll take a string called event name, and we'll use a switch case based on that string. In the case of animation n, the only thing we'll do is set inAnimation to false. Returning to the start, we'll register the onSMB event by doing eventCurator.event.addListener and passing it as the argument. Now whenever the event is invoked, our function will get called. The next step is the crossfade, which I'll add to the bottom of the update. If we are not already in an animation and attack is pressed down, inAnimation is set to true. And we'll call animator.crossfade in fixed time, using the jab state name, a transition duration of 0.1 on the 0th layer, and a 0 offset. Now we have to take care of the translation and rotation while we're in an animation. For now, we'll translate and rotate only if the character isn't in an animation. Before we can test this, we need to set up the events. On the character, add the event curator, and on the jab state, add the SMB event. The timing is on exit, and the event name is the same as our switch case, animation end. Testing this, we can throw a punch, but it doesn't look right because there isn't any movement. We want the character to move with the animation, and the most obvious way to do that is by enabling root motion in the animator. In order to both contain everything to the character controller and to educate, we'll be handling it ourselves. Because we do need root motion, let's get rid of this line and add some new variables. A vector 3 animator velocity, and a quaternion animator delta rotation. Beneath the update, we'll add another Unity message on animator move. This is where you want to alter root motion, but we're just going to get the data. If inAnimation is true, animator velocity is equal to the animator.velocity. Animator delta rotation is equal to animator delta rotation. And be aware, for the animator to calculate these, root motion needs to be enabled. That's why I got rid of that line earlier. Now to use these values, if in animation, new velocity is equal to the animator velocity, else new velocity is what we had before. To handle rotation, if in animation, transform.rotation star equals animator delta rotation. If you didn't know, you can multiply two quaternions together to apply a rotation to an orientation. So here, we're applying the change in rotation calculated by the animator to our current orientation. Now when we punch, our character moves with root motion, and it looks a lot better than before. After implementing the onAnimator move, the inspector of the animator changes, and you get apply root motion is handled by script instead of the usual checkbox. Next, we'll have our character controller implement the iHitResponder interface, and I'll make a backing field for the damage property. Then, I'll create a reference to the hitbox and add a list of game objects to store the things that we hit, and in the start, assign the hitbox's hit responder. In the check hit, we'll make sure we didn't hit ourselves, and that we didn't already hit the object before. This is because the check hit is called over several frames, and we only want them to be hit once per attack. Passing both these conditions will return true. In the response, we'll add the owner of the hit hurt box to the list of game objects hit. We'll expand this further in a bit. We still have yet to call the hitbox's check hit, so we're going to make another boolean, jabbing. This represents when we should call the check hit function. At the end of the update function, if jabbing, then hitbox left fist dot check hit. Then we'll use our on SMB event to set this to true, in the case of an event named jab start. We also need to clear the list of objects hit, as this marks the start of a new attack. Additionally, jabbing needs to eventually be set to false, which we'll also do in the switch, in the case of jab end. Now, we need to invoke these events from our animator. Looking at the animation, between frames 20 to 30 seems like a good place to enable our hitbox. In the state machine behavior, we'll add two new events. Jab start with a timing of update and an update frame of 20, and jab end with a timing of update and an update frame of 30. As the animation plays, these events will trigger, invoking our onSMB event function, which sets and resets the jabbing boolean, and based on that boolean, our hitbox searches for hurtboxes. Next, we need the hitbox, and I'll start by adding an empty to the character's left hand. Add a box collider, scaling it down, and orienting the transform so that the Y is towards the knuckles. This is because we made the hitboxes up as our sweep direction. Disable the collider as it's only used to define the dimensions of the area, and add the hitbox component. Reference the collider, set the layer mask to only hurtboxes, and set the hurtbox mask to just enemies. Then finally, reference the hitbox in the character controller. Enter play, and when we test this, we can see that we do get a hurt response. With our jabs detecting hurt boxes, let's work on the responses. I'll make a new folder for prefabs, and I'll add to it this pretty terrible hit spark particle I made. In the character controller, I'll make a new reference for this prefab, and in the hit response, I'll instantiate a copy. The position is the hit data's hit point, and for this particular particle, the rotation doesn't matter, so I'll just have it as the quaternion identity. On the flip side, in the hurt response, I'll remove the debug line and apply a force to the rigid body. First, we'll calculate a force vector. The direction could be the vector between the character and the object hit, but I'll just use the negative of the hit normal. And since we don't have any HP, I'll make use of the damage by making the force directly proportional to it. Then, let's call the rigid body.addForce with a force motive impulse for an instant force that accounts for mass. Lastly, we just have to reference the hit spark in the character controller. Let's play, and I see our punches are weak sauce, so let's pump up those damage numbers. Now we're getting somewhere. Let's not just stop there, I want to be able to one punch. So let's up these numbers again and make these character joints breakable. Well, that wraps up what I had for combat. Of course, that doesn't mean it's the end. Some things you can try on your own are comboing, tracking, and obviously creating something that fights back. If you like the series, keep tuning in for more content like it, and I'll see you in the next one.